Children, it is a continuation of the chapter Areas of Parallelograms and Triangles. Now let us continue the exercise 2 of the chapter, the fourth question. What is that fourth question? In a figure, P is a point in the interior of a parallelogram ABCD. Show that area of triangle APB plus area of triangle PCD equals half into area of parallelogram ABCD. First one. Second one is area of triangle APD plus area of triangle PBC equals area of triangle APB plus area of triangle PCD. Now, here let us draw the line through P parallel to AP to prove the first one. Now, let us draw the line passing through P and that is also parallel to AB. So, this is a line parallel to AB and also parallel to CD, because you know that if you draw the line parallel to AB, it also becomes the line parallel to DC. So, let us name it is MR. You can give any name. So, let us name it as MR. And here you write the solution to prove that first one. So what is the construction here? You write given ABCD is a parallelogram and you draw MR parallel to AB. So you write given that ABCD is a parallelogram and here AB parallel to CD and AD parallel to BC. So let us draw MR parallel to AB. MR parallel to AB. So, or otherwise draw the line. Let's draw the line MR parallel to AB through the point C. Through the point P. Now, here you know that here MPR is parallel to AB and AB and CD, as AB and CD are parallel, MR is also parallel to CD. So you can write, therefore you write MR parallel to AB and AM is also parallel to BR. And you know that here triangle ABP and the parallelogram ABRM are on the same base AB and between the same parallels AB parallel to MR. Therefore, you can say that here area of triangle APB is half the area of the parallelogram ABRM. Similarly, you can have here area of triangle PDC is half the area of the parallelogram MDCR, and by taking the addition of the first and second, if you consider this area is first one, this area is second one, then you will add that two to get that area of the triangle APB plus area of triangle DPC is equals to half the area of the parallelogram ABCD. So let us write here. You write triangle APB and parallelogram ABRM on the same base AB and between the same parallels AB parallel to MR. AB parallel to MR. Therefore, you can write that area of triangle APB equals half into area of parallelogram ABRM. Area of ABRM. So you consider this is the first. Similarly, triangle PDC or triangle PCD and parallelogram MRCD are on the same base DC and between the same parallels MR parallel to DC. So you write similarly triangle PDC and parallelogram MRCD are on the same base DC and between the same parallels MR parallel to DC, same parallels MR parallel to DC. Therefore, again you can write area of triangle PDC equals half into area of parallelogram. This parallelogram, what is that parallelogram here? MRCD here. These two are on the same base and between the same parallels. Therefore, area of the triangle is half the area of the parallelogram on the same base and between the same parallels. So you consider this is the second. Now you add this first and second. LHS and LHS must be added. RHS and RHS must be added. So LHS plus LHS. So you take by first plus second. Take area of triangle APB, plus area of triangle PDC equals half into area of ABRM plus half into area of MRCD. Then here you can write area of triangle APB plus area of triangle PDC equals what? Half into You can take area of ABRM plus area of MRCD. Here half is removed at a common. So in the bracket you will get the sum of the two. Then it becomes half into the area of sum of these two. Area of this parallelogram plus area of this parallelogram adds up to the area of parallelogram ABCD. So you will get the area of parallelogram, whole parallelogram ABCD. That equals half area. You write here area of triangle APB plus area of triangle PDC equals half area of ABCD. So you got the proof for the first one. Now to prove second one, that is area of triangle APD plus area of triangle PBC equals area of triangle APB plus area of triangle PCD. And here we got that area of triangle APB plus area of triangle PDC is half the area of the parallelogram ABCD. So let us prove the sum of the area of triangle APD and BCD is also half of ABCD. Then to prove that area of triangle APD plus area of triangle BPC equals half of the area of parallelogram ABCD, we have to draw the parallel line through P, that is the line must be parallel to BC and ED. So let us draw the parallel line here. So you take, that is a line SQ. So let us draw. Let us draw SQ parallel to AD. SQ parallel to AD. Therefore, you can say that SQ parallel to AD and SQ is also parallel to BC, because it is given that AD is parallel to BC as it is a parallelogram. ABCD is a parallelogram. Now let us take this triangle. Triangle APD is and parallelogram ASQD are on the same base AD and between the same parallels SQ parallel to AD. So write triangle APD and parallelogram ASQD are on the same base AD and between the same parallels AD parallel to QS. AD parallel to QS. Therefore, you can write that area of triangle APD equals half area of ASQD. So you consider this is the third. Similarly, have this triangle and this parallelogram. They are on the same base BC and between the same parallels BC parallel to SQ. So you write similarly triangle BPC or PBC and triangle and parallelogram BSQC BSQC are on the same base BC and between the same parallels SQ parallel to BC. SQ parallel to BC. Therefore, you can write that area of triangle BPC equals half area of BSQC. Half area of BSQC. Consider this is the fourth one. Now you add this to LHS plus LHS, RHS plus RHS. So you write from third plus fourth, you write that is LHS means area of triangle APD plus area of triangle BPC. Area of triangle APD plus area of triangle BPC equals half area of ASQD plus half area of BSQC. That equals what? Half into the sum of these two equals sum of these two. That is nothing but you will get, remove the half common here, area of ASQD plus area of BSQC. So you will get that equals half into area of ABCD. That is, you take here from first, this is consider second, and this is the first one what you proved here. That is area of triangle APD plus area of triangle BPC. So from first and second, you know that LHSR here equals to, here this area is equals to half area of ABCD. Here also this area is equals to half area of ABCD. As RHS are equals, LHS must be equal. Therefore, you can write that, what you can write here, this area is equals to half area of ABCD. This area is also equals to half area of ABCD. Therefore, from first and second, what you can say, area of this area of triangle APD plus area of triangle PBC equals area of triangle APB plus area of triangle PCD. So you write area of triangle APD plus area of triangle BPC equals area of triangle APB plus area of triangle APB plus area of triangle PCD. You got the second also. Now the fifth question, PQRS and ABRS are parallelograms and X is any point on side BR, show that area of PQRS equals area of ABRS and area of AXX equals half area of PQRS. Half area of PQRS. Now, here, how you can prove this one? You know this, these two parallelograms, parallelogram PQRS and parallelogram ABRS. Parallelogram PQRS and parallelogram ABRS are on the same base SR. Both the parallelograms are on the same base SR and they are between the same parallels PB parallel to SR. PB parallel to SR. So their areas must be equal. Therefore, you can write this one. Second one, here you know that triangle AXS and parallelogram ABRS. Parallelogram ABRS are on the same base AS and between the same parallels BR parallel to AS. So the area of the triangle AXS is half the area of the parallelogram ABRS. Half the parallelogram of ABRS. But you know that these two are equal, means naturally you can write in the place of ABRS, you can write PQRS. So let us write here. So you take the solution. Write the solution. What is given here? Given that PQRS and ABRS are parallelogram and X is any point on BR. X is any point on BR. Now to prove the first one. So let us take to prove area of PQRS equals area of ABRS. To prove first one. So you write that two parallelograms are on the same base and between the same parallels. So you write that parallelogram PQRS and ABRS are on the same base, which base? SR. Same base SR and between the same parallels SR and PB. SR and PB. SR and PB. Therefore, you can write that their areas must be equal. Therefore, area of PQRS equals area of ABRS. Area of ABRS. First. So, to prove second, we proved that area of PQRS equals area of ABRS And now you take this triangle. Triangle AXS. Triangle AXS and parallelogram ASRB. ASRB are on the same base. Which base? AS. They are having the same base. AS, and between the same parallels, AS parallel to BR. AS parallel to, here these two are parallel. AS parallel to BR. They are between the same parallels. Therefore, you can say that area of triangle AXS equals half into area of what? ABRS. ABRS or ASRB. ASRB. Now here you take this is first, this is second. So here in the place of ASRB or ABRS, ABRS same, you can write area of PQRS because these two are equal. Area of ABRS equals area of PQRS. Therefore, you can write, area of triangle AXS equals half into area of, in the place of what? ASRB, you write PQRS. PQRS, that is from first. You consider no required. You write from first. From first it is. So you got the proof of the second also. Now the sixth question. A farmer was having a field in the form of parallelogram PQRS, and she took any point A on RS and joined it to points P and Q. In how many parts the field is divided? What are the shapes of these parts? The farmer wants to sow wheat and pulses in equal portions of the field separately. How should she do it? Now, let us have the solution here. So, what is given? PQRS is a parallelogram. A is a point on SR. A is a point on SR. AP and AQ are joined. AP and AQ are joined. Now here you can say that triangle APQ and parallelogram PQRS are on the same base and between the same parallels. So the area of triangle APQ is half the area of the parallelogram PQRS. So you write triangle APQ and parallelogram PQRS on the same base PQ and between the same parallels PQ parallel to SR. Therefore, you can have that area of triangle APQ equals what? Half area PQRS. Now, here you know that then the remaining area, the sum of the area of the triangle APS and area of the triangle ARQ must be equals to what? Half. Here that is also equals to half. Therefore you can say that here you write, therefore the remaining what is remaining? Area of triangle APS plus area of triangle ARQ equals half area PQRS. Therefore, you can show that area of triangle. So, you consider this is first, this is second. How it is half? This is half means the remaining must be half. So, here you write that area of triangle APQ equals area of triangle APS plus area of triangle ARQ. So you got that area of this triangle APQ is equals to sum of the area of these two triangle. So if she want to sow wheat and pulses in equal area, she can grow wheat here and pulse here, or she can grow wheat here and pulse here. Then the sum of this area is equals to this area. Two chances are there. She can sow the pulse and wheat in two ways. So you write, so farmer has two options. Two options. One is she can sow, first one, wheat in triangle APQ and pulses in triangle APS and triangle ARQ. So here what happens? The wheat and pulses are in the equal areas, or here pulses in triangle APQ and wheat in triangle APS and triangle PRQ.